Okay. So yesterday we solved the car dataset problem and yeah, Jenny has completed. What about others? It's a simple model that we have to build up. Okay. Very simple. Okay. Uh, how do you build that model? Okay. How do you build that model? So the problem statement that we are having here is we have to build a simple model like we have that car data set and we have to solve the problem here. Now, what are the ways we can go and we can build this model? Basically, we are trying to read the data set, and on the basis of data set, we are building a regression, basically logistic regression model to make the prediction about the car data set that we are having. I'll share my screen quickly. Okay, coming back to the car data set that we are using, give me a minute. Next AI. So here we want to make a prediction. Okay, we want to make a prediction for a car data set. We have taken a very simple example just to understand how it is working. Okay, so this is a car data set that we are having, and if you remember yesterday we discussed about the steps also that would be required to solve this problem. So how did we start? Initially we started importing all the libraries. Okay, the steps are simple. I have shared the steps also with all of you. Okay. The steps are very, very simple. These are the steps you have to follow. Starting from importing library, you go and read your data set, check the model, do EDA on that, check for missing values, check for outliers, check for categorical data. If it is there, convert that to numerical, standardize the data set, visualize your data set, univariate, bivariate, multivariate, split the data set, and import your model like training and test set. This is what we are doing right now. So this is our model. This is our data set, car data set we have taken. So let me upload the data set also here with just to show you all. Again, this is a simple sample that we are having now. This is an CSV data set. So I'll say read underscore CSV. This is also CSV. Okay, so let's read this data set first. We'll check the first 5 records. This is fine. Then you can see here we are having gear. Okay, different types of gear that car is having. For example, type 3 gear, type 4, type 5. So in these gears that you're having, type 3 and type 4 are manual. Okay. This type 3, type 4 gear are manual. Type 4 and type 5 are automatic gears, like gear that we are having in the vehicle. So we have it here. Less of type 5, but more of type 3, type 4. Then you can check the shape of your data. You can do info. Yesterday we did all these things, info and all. We saw what we are having. Then your data might be having some mean values. Okay. Like null values and all. You can check. How do I check the null values? I can say car dot is null. If you remember, okay, it's cars. So cars dot is null dot sum. If I say right now there are three missing values. You can see here both the places. How do I handle that?
Fill
Use
any.
fill NA. So we are running it here by using fill NA. It will take care of it. Now again you can check your data like this. Okay, this is good. Then we can create a box plot. Like if I want to check my data set, whether it is having some outliers or not, if you want to check, Go and create a box plot. So simple cast dot box plot you can get. So you can see the spread. These values are spreading less, whereas these columns are spreading too much, and HP seems to be having some sort of outliers here. Further, null and all we handle that. Now we don't have any null value. Go and check it again. 0, 0, 0. Good. Create your X and Y. Like X is having the car data set. We have the count of it. Like how many are automatic and how many are manual. So you can get like look at the count of this. This is automatic. This is manual. This is not looking good. A simple PLD dot bar plot is not looking very good. Okay, that is having count and the index. So what we can do, we can use Seaborn here. Seaborn is actually a better library compared to Matplotlib. It is built on top of Matplotlib. So here you will see we are having this X that is AM, that is nothing but automatic manual. So 0 stands for manual, 1 stands for automatic, and then you're having this color code also like red and blue. So this is giving, if you look at the graph, this comes better. That is the only difference. Then you want to find out like, okay, in my gear system that I'm having, how many belongs to manual, how many belongs to automatic. Okay. So what we are taking two columns together now. This was one column. This was one column like automatic manual. We have a second column gear also that is having three types. Type 3 gear, type 4, type 5 gears. How many of them fall into automatic? How many of them fall into manual? We'll check it here in this code. So you can see we are telling okay, Seaborn, and then count plot. We are taking X as automatic manual column, and then we are telling in that you will add one more dimension. I'm adding my gear. Now you tell me, give me a rainbow color. Tell me how many belongs to this. Now you can say this is your manual type of gear. This is type 3, type 4. So if you see, most of the gear that we are having belong to type 3, type 4 in manual. Whereas in automatic one, that is one, most of them are type 3 and type 5. Yeah. Yesterday's session was there, Jadit. You need to join that group. I'm posting in that. Okay. So maybe you can get the recording. Yesterday we have discussed about these things. So it is coming in GNI group. I'll add you to that group. Okay. Basic. So you can go through the recording. Yesterday we have just covered very basics. That is NumPy. Yeah. So here, as you can see, we have these type 3, type 4, type 5. Now we can understand that type 3 and type 4 belong to this and 1, 2 and 5. So here we check the columns. Yeah, so see, I'll tell you one thing. These courses, like this entire training that we are running is for GenAI, and most of the students have done a registration. Those who have not done, please complete the registration because this is going to be a closed group. Maybe after some time, I'll just close it when we start with most of the NLP topics and all. So those who have not registered, please register, complete your registration so that we can. I can. I will be creating a new group once I start the NLP. I will add you in that. Okay. If you have any doubt, maybe you can pin me. The group link, GenAI group, I'll share it. You can join it in that. But this is going to be till we complete the basic concepts and all. After that, there will be a specific group where I will be only talking about NLP and GenAI. Fine. So coming back to this, we are looking at these cars dot column. So we have these training and test samples. So you take your gear system like automatic and manual, MPG and weight. Okay. So we are running this. Then we are splitting our data. Yesterday I gave you the cheat sheet, all the cheat sheets you will find, which I've already posted there. So there's a Google Colab group. There's a classroom group that uh, if you have joined the classroom, you will find the links there. Okay. So let us go to classroom and see. So if I go to Google Classroom, uh, Yesterday I've shared some cheat sheet with all of you. Okay. That cheat sheet is having the steps. Whether like in scikit-learn, if you're solving any problem, what are the steps that you should be following? Okay. So if anybody has not joined this, who is in this session, please go and join the class. The link is in the chat. You will find it. Okay. This is the class link where we get all the materials. So you can go and join it here. So yesterday I shared these cheat sheets. So cheat sheets are basically this is having some reference like when I'm solving this problem, what are the steps involved and which are the important libraries that we required. So this is shared with you. Please go and check this. It is in the folder. So further we are splitting our data into training and sets. So you can see the model that we are using is logistic regression here. So split your data, then get a logistic regression model, then make a prediction. And finally, what you do, you go and evaluate the model accuracy. Okay, what you will do? You will import train test split. Like we discussed, 80% data goes for training, 20% goes for testing. Your model is logistic regression here. Go and train your model and then you make the prediction. Okay, whether it belongs to this is your prediction, this is your actual. Now if you compare, actual is 0, prediction is 0, actual is 0, prediction is 0, actual is 0, prediction is 0, actual is 1, prediction is also 1, this is 0 0. So this is 100% accuracy. Now let us check that. So for that we have this confusion matrix, okay, which you see here. So we'll run this confusion matrix. Accuracy is 100% is coming here, and then we have this classification report here, okay, which you all can see. So I'll share this notebook with all of you. Please go through this notebook. Okay. You run this, complete this exercise, and then we'll move to the model deployment, and then I'll come to the feature importance. So we'll go one by one to each of them. Okay. Or maybe we can. How did we conclude feature? This is based on our understanding. How do we select? I'll talk about that in some time. Okay. But just go and run this notebook. Okay. That is logistic regression that we are talking about. So I'm just adding this notebook in this classroom. I've shared the link also. Okay. So coming to the feature importance, there are certain ways of solving that. We'll discuss that also. Like how do I select the important features here? Okay. I've shared this in the note classroom also, where you have logistic regression. You can just go through this quickly. Okay. Uh, if you can just quickly go through this, how do we actually go in? We'll look into feature importance also now. Okay. One by one, we'll keep on understanding. And we'll also discuss about the deployment part. AUC ROC curve is basically a plotting technique that you are having here. Okay. So I don't think we have in this AUC ROC curve, but what it does, it tells you how much of area under curve. It's kind of what we are doing. Okay. The It's just giving you the visual representation of what we are doing. Okay. In terms of a graphical way, like what does it shows you here in this output that you see here? It gives you a graphical view of that. Now, for example, if I draw a curve like this, now if I draw one line, now if I ask you, this area is how much? 100%. Now if I draw one line, okay, like I have drawn one line in the center. So what happens? 50% area here, 50% area here, right? So this is what you're having, 50% area, 50% area, both the sides. Now suppose you say that, okay, I want to cover more areas. Okay. So let's say you go like this. Okay. What area are you covering? 60%. If you go like this, what area are you covering? Maybe around 90%. Okay. So this is called as area under curve. How much of area? Here I will have only 50% area. So this is called as area under curve. We call it as AUC. So in our case, if I go it like this, if I cover everything, what it means? 100%. So if we have to draw the AUC ROC curve for our case, okay, it area under curve will be 100% because it is showing like that. Now if I want to draw, if I want to look at what is ROC, the line that you are having, okay, this line, the curve that you are drawing is called as ROC. It's receiver operating characteristics. So the name has been given, but that is a curve actually. And then you have AUC. AUC is nothing but how much of area I'm covering. So if your accuracy is 80, like it's 100%, it will be like this. Okay, complete area is covered. If it is 90%, it will be something like this. Okay, if it is 80%, how will your AUC ROC curve look like? How does your AUC ROC curve look like? It will be something like this. Okay, if it is 70% or let's say 50%, how does it looks like? It is like this. Give me a minute. Just give me a minute. So this is how this works. AUC ROC curve. Have you understood this? Uh, yeah, it will consider all the columns. Basically, ideally, when you run these NA ones, when you're running text data, basically, see, you cannot replace text data by mean. That is a problem here. So what we can do in this case, like it is also giving you some sort of warning that I want to replace this. So it is giving you some sort of warning that you have to be careful when you're solving this problem. Yeah, but then it handles right now all the columns. No, for multi-class classification, it is not going to be binary. Okay, for multi-class classification, it is not going to be binary. Okay. If you're asking only for if you're asking only for logistic regression, logistic regression is always going to be a binary output. Okay, it is never going to give you, it is always going to give you a binary output. It is never going to give you any other sort of output. So remember, if you're using logistic, think about it, always giving you a binary output. Text data is of no meaning. Basically, why? Because if I have a, let's say, gender, think about this situation. You are having gender missing. Now, let's say you are having a gender missing there, like you're having male, female. There is some data that you're having missing that is having gender, like male and female, like this. Okay, male, female, male, female. Imagine if there is some gender missing, what you will do? You apply some sort of maximum value. Now, most of the people in this data are male. So suppose if most of the people in this data are male, what will happen? If most of the people in this data are male, what will happen? You will get a prediction as male. Now the name, if you say, is, for example, the name that we are having, you know, it could be some name, okay. And then if you look at gender, it's actually male. For example, the name is Preeti, for example. Okay. Now, if you look at gender, it is male. So that is not a right way of solving this problem. Okay. That is going to create some sort of issue there. Anyway, now we have saved this model. Okay. Now, when we are making this prediction, I hope everybody understood this, right? Now, if you want to save the same problem, okay, like I want to, so we are making a prediction here. This prediction is good, quite good. Now I want to find out of all the features. Now here we have been very selective. Like if you look at this example also, we have selected only these three features. Okay, we have selected only these three features that we are having. What if I want to go with identifying the feature? Now what are the ways of solving this problem? So there are three ways of solving this problem that we are having. Basically, to answer the question about feature importance, when you want to understand about feature importance, you would like to know, okay, here I am selecting the feature. How do I select the features? These features that we selected, it was, we said, okay, out of all these features that we are having, x1, x2, x3, I will select these three features. What if I don't know? Okay, let's say, what if I don't know and I have to go and select the feature? So how do I go and do that? So there's a three ways of doing that same thing. Okay, what you see here, what are the three ways of doing that? One is called as feature selection method. That is called as filter method. Okay, that is called as filter method. In this filter method, what we are doing, we are trying to run this, and we are trying to find the correlation. So the first one that you see here, what we are doing, we are trying to find the correlation. Okay, what is correlation? Correlation coefficient is telling you that how strongly the features are related. Let's say I am having certain features, so how strongly those features are related. How strongly, how strongly the features are related to your y. Y is your prediction. So if I have x1, x2, x3, and I want to find out what is relation between them, like what is the part of contribution of each of them. How do you find out? By doing correlation method. So you take all the features. Now we are not going to skip the features. You take all the features and see what is the relation of each of them in terms of your prediction. That is a correlation analysis. So there are different ways of doing that. Like in statistics, we are having chi-square, then we are having Pearson's correlation. There are different ways of doing that. So if you want to look at like chi-square and all, those are basic statistical ways. Okay, Pearman Sola, their techniques. We'll do some coding on Collab notebook. We'll see. So this is one way of solving that problem. The second one that you are having is wrapper methods. Okay, wrapper methods, they directly use a machine learning algorithms to evaluate the process. So what they will do, they will divide your data by subsetting your data. For example, I have 10 features, they will take 3 features at a time. You have to mention how many features you want to take. And then they will run that kind of a loop. 3 features and what is the accuracy? Next 3 random feature, what is the accuracy? Next 3 random feature, what is the accuracy? So this technique, the feature selection that we are having wrapper methods, there are two. Like initially you start with, let's say, if you're going with forward selection, you select no feature. You start with no feature, then you keep on adding one feature and see how is your model performing. Simple. Keep on adding one feature at a time and see how your model is performing. This is called as forward selection. Then we are having a backward selection. Backward selection means what? If I have 100 features, keep on dropping one feature, build a model. Like take initially, you take all 100 features, you take all the 100 features. Okay, what you do? You take all the 100 features and then make a prediction, build a model. Next step, you drop one feature, make a prediction, look at the accuracy. Next feature, next step, you drop one feature, look at the accuracy. So what happens? Start with all the features. Okay, dropout is different, sir. Is dropout you randomly drop. Here it is not like that. Here you keep on dropping every time one feature. That is random. I lost certain weight at every layer, but that is not lost completely. Next layer, that weight might be there. So dropout is like, if you look at the concept of dropout, what is happening there? Let's say I have so many features. At one layer, I will drop these feature. In the next step, I'm going to drop this feature. That feature may be retained there. It might be there. It is not drop. Only these features. So randomly, every step you drop certain features to prevent the overfitting. So dropout, you're not losing data. Only one part of data you're just losing randomly, but you retain that in the next layer. Here what happens, out of 100 features I will build a model, make the prediction. Okay, then you take 99 features, you're losing one feature, you prepare a model, make the prediction, look at the accuracy. Then you take 98 features, you keep on going till you last with one or two features, and then you check the accuracy, like whether it is 20%, 30%. So where, which feature, like let's say after 100 feature I was getting accuracy around, for example, 90%, because there was certain feature which were not contributing much, so that was decreasing the accuracy. Let's say I drop certain feature, I took only 90 features. Okay, or maybe I took only 40 features, it is giving me accuracy of 95%. Okay, because unnecessary 60 features we have got eliminated. So this backward selection, you keep on dropping one feature and see what is the effect. So you will come to know the effect of every feature. Okay, like if suddenly some feature is dropped, your accuracy is dropping tremendously. Okay, for example, let's say after 100 it can also happen like this. I'm getting 90 till feature 80. Even if I keep on dropping features, it is only 89% accuracy. So you can see 20 features I drop, how much my accuracy drop? Only by 1%. So what do you understand here? These 20 features that we drop, they are not important. Why? Because sorry, from 100 to 80, like I drop 20 features, how much is my accuracy affected? It is by only 1%. So these 20 features are not important. And then you see which feature you get tremendous drop in the accuracy. Are you understanding? Where my accuracy is dropping by 5%, 4%, that means that that feature is contributing more. I hope everybody is understanding that. It's a simple way, you keep on dropping your features. Where there is a more drop in accuracy, those features will be important. You can find out. Okay, manually you can go and find out. So this is called as backward selection. Then we are having something called as recursive feature elimination. Okay, then we have a technique called as recursive feature elimination. What happens in this technique? Yeah, this is different from PCA. PCA is different technique only. It reduces the dimension. We are not doing that here. Then we have something called as recursive feature elimination. Recursive feature elimination, if you see, okay, with short form we call it as RFE, recursive feature elimination. So what happens in this recursive feature elimination that we are having? The model, if you go and you rank the model, then what it does, it tries to rank the feature. Okay, it tries to rank the feature that what we did in the previous step. Give rank of 1, 2, 3, like based on the order that we are having in a recursive way, which are the important ones, which are not important ones. Okay, so yeah, which contribute less, which contribute more. So these are called as recursive feature methods that we are having. Okay, then we are having, okay, so this is good technique which ranks your feature. You can look at top 10, top 20 features, and you can make a prediction that okay, these are my important features that I'm having. Then we are having this embedded models. Okay, when I talk about embedded models, what is happening, the feature is built, okay, on the model training process. How it happens, let's take example of, we have something called as regularization parameter. So technique we are having is regularization parameter. What you do here is that in this technique you try to apply some sort of penalties. Okay, what you do, you try to apply some sort of penalties to the coefficient. Okay, so here when we do these uh, features which are least important, if you try to apply a penalty, okay, they will become zero, and feature which are more important, they will not become zero. It's kind of multiplication that you're doing. Okay, so coefficients which will be having least important will become zero because they will have a small values. Features will be having more important, they will have high values. Okay, so this is one technique. Other way of solving this problem is using decision tree and random forest. Okay, other ways of solving this problem, how do you solve this problem, you can still solve this problem using decision tree and random forest. Let me write it down here. Okay, so we can have the regulation parameter, like example L1, call it as the different techniques. I'm just putting here lasso, and then you can have a decision tree or tree based algorithm, or maybe a random forest here. So you can have a random forest techniques. Okay, and then you can run. So when you ask me how do I know the feature importance, these are the major ways of getting the feature importance. Okay, any question here before we move forward? Okay, so here we can try one of the techniques. Okay, we can try one of the techniques and see how it is performing. But just to give you the comparative, like how we can actually go and solve, I've prepared one Excel sheet. Okay, kind of spreadsheet that we are having, which is talking about feature importance and all these methods that we are having. Okay, so let's open that sheet and share that with you. So I'll share that sheet with you where we are talking about this feature importance. Okay, yeah. So one sheet I'm having, which I will share with you. So what are the different ways and what is the pro and cons of each of them? So these are the three techniques. What is the advantage, disadvantage of them? Okay. So you have all of them here, advantage and disadvantage of each of them, how you can use them. Uh, okay. So like using filter methods, you can rank them independently. What are the some of the techniques and what are the other ways of looking into this? So I'm going to share this sheet with you, which is talking about feature importance. Okay, and different ways of handling them. So I'm just saving it inside your classroom itself. Now we are going to work on these. We'll select one or two of them and we'll work on that. So let me download this and put it in your drive. Classroom drive, I'm sharing it there. My system, I don't know, suddenly it is becoming slow. Okay. Material, feature importance. In machine learning. Okay. I'm just sharing it in the machine learning folder. Notebook Shriram, I just shared. It is the same notebook. It is in this machine learning folder itself. Logistic regression folder number 5. It is there. Okay. Just check it. 5 number that you're having is already having this. So where is feature importance? Okay. I have to pull it down. Okay, so you have this feature importance. Please go and check this. We have written certain scripts for linear regression, logistic regression, and feature importance is what you can see here. Just go and check this, and we'll do one exercise on feature importance after this.
மார்க்கெட்டே போலையா? அம்மா ஏதோ வெங்காயம் எதனா வாங்கிட்டு சாப்பிட்டு like
I'm just putting you all on mute. I think there was some background noise coming. What category that variance? VIF is again, it's when you look at VIF, it's a recursive feature elimination. You look at the variance, okay, and you're trying to make the predictions. No, embedded methods are basically, they are like algorithms only. So we have these algorithms where you have to, like, disaggregate random forest. So what happens with them? Already we are having, if you look at that, we already have the algorithms. Okay, we already have the algorithm. We don't have to do anything there. You just have to go and find out the output that you're getting. So that's like a very advanced way of solving the same problem that we are doing here. Yeah, you have to pass all the features here. Okay. Now let us go and look into recursive feature elimination. I'm going to share one notebook with all of you. Okay. And we all are going to work on the recursive feature elimination technique. So what it does, recursive, as I said you, this method, recursive feature elimination, or you also call it a stepwise linear regression, like you go here. So this technique will try to take different features based on whatever model that we are building. I'll share you a pseudocode with you. You all can try that. Okay. Save, save. Okay. So we all can try this. Give me a minute. I'll open this notebook. So when we are talking about feature importance, let us take one example and try to discuss that. So I'm just giving you a pseudocode. You can apply this to your notebook. Okay. Whatever notebook you are having, you can apply that to your code also. So like you can go with stepwise linear regression, keep on dropping one feature, look at the output that we are having. Or even the correlation part that I was showing you. Like you can go with the correlation and you can check how your model is performing, whether it is doing good job or not, what kind of prediction the model is making. So this. Okay. So here we have the recursive feature elimination method. If you notice here, uh, so in recursive feature elimination that we are having, we import all the libraries, load your data set as you're loading. But if you see here, the model that we are having is logistic. If you look at this base model, now what we are doing in that base model, we are selecting only two features. Like you can select three features I have. Go and train on that. Okay. Go and train on that. So this is going to be random features that you select. Then use the selected feature, you train the model and look at the accuracy of your model. So what it will do, it will give you the top features that we are having. So what you do, what I want all of you, I'll add this in the classroom. Please go and put your empty car data set on this model and see how it is performing. I'm adding it right now in that folder itself. So what I want from all of you is that go and try. See, this is a code I have given for recursive feature elimination. Only you have to just put your car data set here. That's it. So try on this and see if you can make the prediction. Okay, you can find out the important feature like top two features, top five features. It will iterate on that and it will get. So I'm adding it here right now in the same notebook that we were having, same folder, that is feature importance. Why it is asking for login? Okay, so I'll update just here itself in this folder. Edit, and after edit, uh, just adding it to this notebook. I'm adding it to that particular folder. It's the link that we are having to that itself. Please go and try to use the same data set, the car data set that we are having for logistic regression, to find out the important feature and tell me, like, use this recursive feature elimination method, okay, to get the top features from there. So I've just updated the link. Can you all go and try this one? Feature, it is in the feature importance. Okay. So try this, and top two features out of your 10 features, which are the important ones, like top two, top five. Okay. Yeah, based on the recursive feature elimination. We just now discuss how the recursive feature elimination works. It is doing a lot of permutation combination and it is giving you the output. Okay. That you can get it here. So can you all just go and try? Meanwhile, I just stop sharing my screen. So this is what we discuss about recursive feature elimination. I've shared this. Yeah, that is based on the correlation. Uh, Between the features, between your inputs and the outputs that you are having. So I've shared the code. Please go and try this.
So, Alok, this is Ashwin here.
Yeah, sure.
So, based on what you just said, RFE does take care of the job of identifying what are the top N features which are mostly, highly correlated to the dependent variable, right?
Yep. So how it does?
So, yeah, how
How
it
it?
does is the question I have. Like, yeah.
Yeah. What it does is that it's eliminate. Like we discussed about that technique, right? If you remember, forward selection, backward selection. What happens in that? You start with, let's say you're having 100 features, 100 like x1, x2, 100. So what you will do? You will not start with 100. You'll start with one feature, make a prediction. So with one feature, you will, let's say accuracy is only 10%. Then you added two features. What is the accuracy? Now it become 11%. So you can understand the feature 2 is bringing only 1% accuracy. Now you add one more feature. Now you got three features. You make a prediction. You got a prediction of 15%. When I bought the feature 3, my accuracy is changing by 4%. Means this feature is contributing 4% towards the prediction output. I hope you're getting this. Then I got feature 4. Let's say it gave me 15% accuracy. What it means, this feature 4 is very, very important for me. Recursive feature elimination does the same thing. What it does, it will do like what forward propagation, back propagation we are doing here. So it is also iterating in the same way. And after doing that, okay, what it does, it is eliminating, it is not adding. For example, it is kind of back propagation. You start with 100 features, then you keep on dropping 111. Look at the prediction. Let's say 100 was giving me
Mhm.
90. Now it is giving me 90 again. So I know feature number 99, the one that I dropped, doesn't matter at all. Now I'll go with 98. Now I know that, okay, one more I drop. What is the change in the accuracy? With 98 feature, I build another model. It is hardly change in 0.1%. It doesn't
So
matter.
internally, it will take care of dropping and return the best features,
Huh.
best and
So
features, whatever, right?
exactly. So what you're doing, you're dropping features and you're looking how much they are contributing. Same thing,
Mhm.
this we have to do manually. Same thing we are doing here by using that particular way, where what it does, it is going to eliminate the least important feature in a recursive way. What is meaning of recursive? Iterative way. Lot of iteration it will
Okay.
do. We don't have to go and run that like 190. It will do. It will take all those permutation combination, and then it is going to give us a rank. That okay, this was your top important feature. This was your second last. I think I'm not sharing my screen. That is the problem. I was actually discussing, and but I hope you are understanding
Okay.
what I'm telling.
Right, right. Yeah.
So okay, let me share this. What I was telling is here. So this is what I was. So this is what I was discussing right now. So if you look at these models, what I was telling is that okay, in forward selection, I can select feature 1, 2, 3, 4. Check accuracy every time I'm adding new feature. In backward, I said okay, 100. What is the accuracy? 19. What is accuracy? What 98? What is the accuracy. So here what it does, recursive feature elimination, it what it does, it is going to a recursive function. Okay, it is going to keep on repeating, dropping every feature and see how much is the contribution in a very iterative kind of manner. And then it
Mhm.
will tell you that these are your top. That is up to us. I want to find top 2, I want to find top 10. So it will give you a graph like this, or maybe some numbers where you can, okay, this is my top feature, this is after that, something like, okay, maybe in descending order I'm putting it like this, or in ascending order again you can have like this. So these are your least important, then other features, then other features, or you can have a graph also like this. Okay, or you may be having some sort of numerical values of that, that okay, these are my important features based on this backward selection that I'm doing here right now. Okay, the one that discuss correlation is a different techniques. It is trying to find relation between both of them. That is called as a filter method. This is called as a wrapper method. In wrapper method, you try to drop feature and then see. Embedded are like, they're like an algorithm itself, where you're using like logistic regression doesn't have those tree based approach here, so we cannot use them. But if you're doing classification for some other task, you can use them. Now coming to this, I've actually tested these things here also. So where is that output? I think it is somewhere here. Yeah. So when I was testing this, as you can see in the car dataset itself, I was trying to, now you can see I'm building a correlation map here. Okay. I'm trying to build a correlation map here. So I got this data set. I did car data set, like those features and all. We built a logistic regression. Now I created a correlation plot like data.corr, take your this thing and then sort the values, like whatever correlation value you get in ascending, like you want it in descending order, and then you create a visualization plot like bar plot of all those things. So here you can see the important. So as you can see here, when I do correlation with my y, what is it telling you? That mpg drat and vsam gear and q second, these are important feature which is bringing a positive outcome in the model prediction. Whereas feature like these all, they have a negative correlation. They will decrease the efficiency of the model. They are inversely related to the model. These are directly related. More of these will increase the outcome. It's a direct proportion.
Mhm.
Whereas they have an inverse proportion. They will decrease the outcome because they are inverse value of that. All these features. Now you can understand. This is very very powerful. I have a prediction. I want to know my sales. I'm trying to predict for a sales. Sales in New York region will go down in the month of May, let's say. Okay, tell me the reason for that. So maybe these are the positive impactor of that. These are the negative impactor. From business point of view, what it will do? It will try to control these factors. It will try to play with these factors. That is the power this brings, towards a prediction. But this is a simple correlation of with my y that you see here. Now I show you lasso also here. Like I did a lasso. I'll share this notebook with all of you. But lasso tells you, okay, which are the important feature for you. Like again, it is also eliminating and giving you. The one that I gave you is a recursive feature elimination. It does the wrapper method. What it does here in the wrapper method, it does this backward selection. What I showed you was the filter method correlation. You saw that graph right now. That is different. Wrapper method is different, where you add or delete a feature and then see what is the effect on the overall model. This is like, if I don't use recursive feature elimination, can I do it manually? Yes. Yourself, you take 100 features, make a prediction, note down the accuracy. Now you drop one feature, note down the accuracy, keep on doing it 100 times. Now you only will tell, okay, this feature was impacting so much. The same thing is done by the model here. That's what we are doing in the recursive feature elimination. Then we have other advanced models also to take care of the same thing. Is it clear now?
Yeah, thank you.
Okay.
So do we know, like, I mean, is there a specific scenario when we apply what? I mean, or
No, no, no.
which
There is
kind?
no rule. It is all topic of R&D. So you have to sit down and see which one suits you. Okay.
Okay,
There is no specific rule for this.
okay.
Model selection, you are getting error. Maybe you have to import that. Let me check. It should be in the library. You have to import that from sklearn. If you're having sklearn library, it is having RFE. Okay, just try from sklearn.model selection. Okay, let me check. Yeah, you can import the recursive feature elimination. Just try that. What I will do right now, I'll do one thing. Just give me some time. I was very busy on this weekend, so I'll prepare a proper notes for all of you with a detailed description of all these techniques. Okay, with some example also. I'll share that with you. So maybe I'll sit down in the afternoon. I have some time, so I'll work on that. I'll share that, what are the techniques they are using, and you will get an idea of this. Okay. So I'll post it in your classroom itself by today afternoon. Accuracy is one only because this is very simple data set that we are having. It's a very simple data set that we are having. Now in that data set only, okay, maybe you can modify the code. It is a feature selection, right? It's not model. Fine, just modify that code also. So you all understood. These are the ways, okay, which it is working. There are a lot of other ways also. Like if you look at recently, like I have used something called as lime and sharp method. So when we are looking into deep learning models, so we are having much more advanced. Okay, uh, we are having much more advanced technique. So we are having much more advanced techniques, and what are those techniques? Something is called as sharp. Okay, and then we are having lime also. So what are these techniques? Maybe uh, next session I'll prepare some notes on this. But what they do, like they like if I have an image. Now let me explain you. If I have an image here, so suppose if this is an image. Now when you say this is a cat, okay, how does the deep learning model knows that this is a cat? Okay, on what basis it is trying to make the prediction? Okay, so what it does, it tries to hide certain part of that area and then make the prediction. Same way what is happening here. So it will go and hide a certain portion of that image. Like, okay, what if it hides this portion? Is the prediction still a cat? Then what do you understand? This is not making much difference. Now, okay, what if I shift the area here? Now if I shift this area, like whatever I was masking, if I shift it further, now is it coming? Maybe little bit affected. But imagine if I shift it here, the prediction as a cat will be wrong. Now it is saying no, this is not a cat. So what do you understand? This area of the image is actually contributing in the prediction. Are you all understanding? If I mask this area, then how it is telling like the prediction is cat or not? Okay, whether the prediction is cat or not. How does it knows that? Again, this area will tell it is important or not. So we have these two techniques, lime and sharp. Okay, so which gives us certain range, certain values they could be used. Maybe in the next session I can bring them. We can discuss on that. These are way advanced method to identify the feature importance. These are the way advanced method to identify the feature importance. Okay, so let's take a quick break of 5 minutes, guys. Come back and then we'll talk about model deployment. That is the second thing that I said I'll discuss today. So maybe after this, we'll discuss about model deployment. Any question before we leave? Go for a break.
सर
I'll,
सैटरडे का ज्वाइनिंग ग्रुप लिंक
I'll share that link. Okay, I'll add you in that link. Could you upload? Yeah, I will upload the recording also. Give me a minute. I'm doing it right now. So I've shared the link. You can join this group where this is where I'm sharing all the links of Saturdays and Sundays, both days together. In the chat, you will find the link. So let us take a quick break of 5 minutes and come back. Let us continue. So, as I said, I'll prepare a proper detailed notes for all of you for feature importance. There is a lot of things. Okay. So I'll put it together and I'll share that with you. Today only you will get it in the afternoon. Okay. So that was with feature selection. Any question on feature selection? Have you all understood how it is done? What are the different ways? No question. The second part we can start now about model deployment. See, model deployment is very, very important. And you all know that if some of you have attended the AI session, how much time it takes to train a model. Yesterday I have given an assignment. I don't know how many of you have done, but if you've seen that, it takes a lot of time to train the model. So imagine a situation where you have to go and make a prediction. If any customer comes to a bank and say, okay, I want to apply for a loan, you cannot tell the customer, wait, my model is running, wait for 3 days, 1 week, and then I will tell you whether you're eligible or not. It has to be instant. It has to be immediate. So how do you do that? So you have to save your model, like whatever model that you've prepared, you have to save that model to make a prediction. Now, how do you save your model? Okay. So whatever model that you're having, you create an object. Whatever model that you're having, you create an object of that model. So there are two ways of solving this problem. You want to save your model, there are two things that you can do. One is called as job leaf file. So we say pickle files. Have anybody heard of pickle? Has anybody heard of pickle? Uh, it's a pickle object that is so saving your models. Okay, saving models. What are the different ways you can do that? So one of the ways that you're having, using a pickle. So you can create a pickle object. Okay, you can create a pickle object of this. Now what is pickle objects? Let us do that. Whatever model that we are having, let us create a pickle of it. Other thing you can do, this is a second way of doing that. It is called as job leaf. You can save it as a job leaf file. Okay, job leaf file. You can save it as a job leaf file that you're having, and you can use that. Or if you're using a deep learning model, okay, these are for basic ML models. If you're using a deep learning model, so in deep learning model, right now we have not covered that, but in deep learning model, if you're using Keras, okay, if you're using Keras, we have an option. We can say like save. We can say save dot like model dot save. Model dot save. We can say it like this, and inside that you give a name to your model, like whatever model is there. Okay, like example, my underscore model. So you save your model. For example, you say my underscore model. Okay, and then you say dot h5. This is a format that you're saving your model. Okay, entire model will be saved here. Then you can save the weights also if you want to save the weight. So you can say here model dot save, and then you can say my weights. What is weights? Weights are the training of your model. Those will help you to make the prediction. So if you want to only save the weights, you can say underscore my weights dot h5. Okay, this is in Keras format. I remember that, not PyTorch. I'm just talking about Keras. So this LLM and all that you are having, the large language models, they will also be saved in that way only. So if I go to that website, you can just, yeah, correct. So you can save your model, and then from there you can use. So if you want to actually go, so there are different ways of using this model and all, like save. Let's go and save our model. Can we do that right now? So logistic regression we have done. Let us quickly go and see how it is done. So let us try this now. So we have a logistic regression notebook. Let us go and save our model. Okay. Sorry, it is here. So this is our model, logistic regression that we have done. So when you're telling model dot fit this code, after this code, you want to save your model. Okay. What you want to do? You want to save your model as a pickle file. So let's go and save our model. Okay. Can we try this? So let's go and save our model. So we have done the training here. Now we want to, you can write down the code along with me. Okay. So saving the model, this is only you can deploy this model. Okay. Then only you can deploy this model. So you have to save this model as a pickle object. Saving the model as a pickle object. So here, let us go and save the model as a pickle object. Okay, so let's go and save the model as a pickle object. So what we'll do, we'll write down the code here. We'll say with open and okay, as you can see, it gives me that option, like I can say with open, and then what I can do inside this, I can write the name. Okay, what I want to do, I want to save the model. This model that I'm having, let's give it a name. Okay, logistic. Okay, so you can see I've given a name to this model and I want to save this model. Okay, why it is not going? Okay, so here I'm telling that model I will save as a .pickle file. Which model? This model, logistic. That model you give a name, or I can call it as a logistic model also, like whatever name you want to give, model.pickle, and we are writing. This is I'm writing it as a file. Okay, simple as file, and then you can say pickle.dump model and file. So you run this. What will happen? You will have a pickle file object here. Let us try this now. But problem is that we don't have this pickle module. This pickle is not defined. So what you have to do? You have to import a pickle. Okay. So let us do it on the top. Okay. Or let us do it here only right now. We can just import pickle. So we'll say import this particular module, that is pickle. Okay. Just import that. Yeah. So once you get that, now you can say I want to save my model. So your model will save here as a model.pickle. It takes some time to show you here, but then you can save it here. Now once I save my model, imagine deep learning model, you just save it like that, or any big, because here it is small data set, sample data set, it doesn't take that much of time. But if you're having large amount of data set and it takes a lot of time, then pickle is where it will be very helpful. And for deployment also, now you can see I have a model.pickle. So this is the entire training that you have done. You just need this file. Like I can download this pickle file. Okay. This is the pickle file that I have that is having training of my model. So I'll show you in my this thing. As you can see, I got this. Okay. This is the training of my entire model. I don't need all the code. I just need this pickle file and I can carry it anywhere. Okay. You can deploy it in Docker, you can deploy it in cloud, anywhere you can deploy this pickle file. So these are called as model artifacts. What do you call it as? Model artifacts. So we have this model artifacts, we are having this pickle file. Now let's say I open a new notebook. Now imagine this is a new notebook, let's say. Now I want to read this pickle file. So how do I start? Let's say that entire task was done. Now I want to make a prediction. So what I will do? How do I load the model? Here what we have done, here we have just tried to save the model as a pickle file. We have saved the model. Okay, we have saved the model. Now let us go and try to load the model. So this is done, it is already there. Now let us go and load the model. So it is like, okay, let's say this is totally new notebook that I'm having. I want to load the model and make the prediction. So here what I will do, I will say with open again, in place of write here I was writing, I have to read that file. That's it. So you say read that file and load that particular folder. Just run this. Okay. Now further you can just go and make the prediction like this. Okay. Just see if it is working. Okay. Still you can use. So this is one way you try to create a pickle file of your model. Okay. Pickle objects. So what we have seen here, this is very fast. Okay. This is normally we create a pickle objects and we save the model. Has everybody understood this? How do we create pickle and all? Yeah. So this is one way you carry your pickle file, that is your model artifacts. Now, second one that we discussed was job leaf file. Let us look at job leaf file. Again, for job leaf also you have to import. Okay. So now we'll discuss about your job leaf. How do you use the job leaf here? So using job leaf, job leaf. So again, how do I use job leaf? This is again designed in scikit-learn. It is having built on top of NumPy. So you import your job leaf first. Otherwise, we'll get an error. Now again, we'll take that model.fit. We'll take this file only. model.fit. Now I want to do a joblib file. So I will save the model first as a joblib object. So I'll say save the model. Okay, you save the model as a, how are you saving the model? As a joblib object. So you say save the model. Here you say joblib.dump. Again you can see I'll call it as a model one now, because otherwise both will look same. Not pickle, but I will save it as a joblib. Let us call it as a model only, because extension will be joblib, not pickle. Okay, so you say job and then you say lib. So here I'm saving the model joblib.dump your model, whatever you're having. Okay, and that model, how are you saving? Model.joblib. Let us run this. So here again we'll get one more model. That model will be model.joblib. Now if you want to read that model, okay, how do you read that object? Again, we have created our model as a joblib object. Now if I want to load that thing, again same way, what I will do, we'll try to load the model. We'll try to load the model. How do I load the model? Again, you say I load my model. Here you are dumping. Now you'll try to load the file. Like, no, same way. We can do the same thing with pickle also. It's not different, just a different way of showing you. So you can see model the joblib also there. So you can dump and load these files also, and you can go ahead. So you can see we can create the model artifacts very easily here. Okay, what we have done, we have created a model artifacts. These model artifacts are very, very important. We can deploy this model. Now to deploy this model, what else do you require? You will require a Flask or a Django API. So how do you create a Flask app? I'll show you. To create a Flask app, like I have certain notebooks running here. So how do I go and create a Flask app here? Okay. So you can see I was having one notebook. This notebook, if you see, is having some data. Okay. It is having some album, some year, some data is there. Okay. Data is like this. This is like a JSON. This is like a dictionary that you are having. So you read that data. It is having album, year, and US pick. So that data when I'm reading, it is converting like this. I try to normalize that data. It is coming as a data frame. Then I handle the null values. Now I want to deploy that model using k-means clustering. What do? You create a Flask app. Okay. You create a Flask app. It's a web app that we create for the deployment purpose. So you have to use app.route. You have to use, first you write app.flask. Okay. We are creating here a Flask. So when I create a Flask, you mention app.route. So what is going to go? Like example, this app, whatever we are building, it should be communicating with the outside. This app should be communicating with the outside. So we have get and post here. Okay. What is means of get? How will my data come to this model? Remember, you have that model artifacts, either pickle file or joblib file. Now you have the pickle file and joblib file. Okay. Now you want that data to come and you want to make some sort of prediction. So you will do a get post here. So basically, let's say that data is already coming in my model. I want to make prediction and share the prediction. Okay. I want to share the prediction. So you do a post here. Like I want to share the output outside. So we are having get and post method. Let me write it down. So before I discuss any question,
No, please go ahead.
okay, no question. Fine. So here, what we are doing, we are trying to, let's say I want to deploy that model, it has to communicate outside. Okay, it has to communicate outside. So what do we require? We require certain frameworks here. Like example, there are like right now we are talking about Flask app, or there are Django framework also. So here that we are having, we'll say I want to use a Flask app. Now if you look at Flask app that we are having, okay, so the core idea, Flask app is like a bridge. It is like a bridge between your machine learning model and your external users that we are having. We all know that Where is my code lying? It is lying in the Jupyter notebook. My code is lying in the Jupyter notebook. Now, this is your Jupyter notebook. Okay. So how do I connect with the user outside? So what I have to do? I have to build a bridge. Okay. So what do we call it as bridge? Normally we call it as an API. Okay. What do we call that bridge? So you will be, this is your notebook. There is some sort of UI that you are having. What is that UI? User interface, like website that we are having. So we will be having that user interface. Now, this is a website that I have. So how do I connect my notebook to that website? You know that, or maybe some Python script with that user interface that we are having. So we need some sort of bridge here. Okay. So what Flask is doing, it is creating that bridge. And this bridge entire mechanism that we are doing is called as an API. What do you call it as an API? What is API? It's nothing but an application programming interface. What it does is that it allows the communication between your script, whether it is Jupyter Notebook or whether it is Python script, with the UI, where you will have, remember somebody is having putting name, like you have an option like put your name, that data is putting. This data should go to our model. Okay. And then our model will run something, it will make some sort of prediction. That prediction should come here and we should be seeing some sort of output here. So these things that we are having, how it does, so it is using get and post. What get does, get brings the data here. So if I say get, okay, if I write here get, what it will do, it will bring the data. Okay, it will retrieve the data, okay, from the server. So get request, what it will do, it will fill the metadata from database or from the UI, wherever you have connected that. It is a request like input features, whatever you have. So it will take it to your model. Here your model is running. Your model is running here. Your model will run, take that data, run the model, make a prediction. That prediction will go to the API as a post. So post, what it does, it is sending back. What post is doing? It sends the data to the server, like wherever you are having for the processing. Okay. So it is helping here. Have you all understood this architecture of Flask app? Everybody? Yeah. I think there is some question. Post because why? This is example. This is just example. Okay. You can have different input data. That is not a problem at all. Okay. Whatever data you are having, you can deploy that. So remember, Flask is actually helping us to build that app. Okay, where you can put your data and you can run. In this example that I was showing you, okay, what I have done, we have taken a simple, example to explain you that. Give me a method. Give me a minute. So what, I'm just sharing a notebook with you that is having whatever we have discussed for ML model deployment. So this is an example that I'm sharing with you. Okay. Like how do you run this entire thing? And I'll show you live demo right now. Okay. We'll look into a live demo of how we can use this, and all of you are going to run that. We'll do the testing also today before we end the session. Okay. So whole idea is that only. So let me save this thing. I'll open it here. Okay. So we'll look into so here you can see, yeah, I will not take this example because I just want to give you a basic code of how this Flask work, and we are having this. Save the code here. I'll just try to open it. Is there a continuous yeah, there's a continuous, communication with both of them. Right now we'll do that. Just wait for some time. My laptop is slow because everything I've just prepared for you and it is actually running. It has slowed my entire system. So I'm running a server in the backend, right? Okay. So it has slowed my entire system because of that. But anyway, so I'll come to that server now. I'll show you. So there's an MG Gork and all those things are running there. Because of this, my system has been slowed. But anyway, after this, we'll move to that. So here we are looking into how do I create a Flask app? What is the basic structure of a Flask app? So how do you define the app? You just like whatever we have done, okay? Like we have saved the pickle file. So we just discuss about pickle and the jobly file. Now let us move one step ahead of it. So now I want to build a Flask app that should be able to communicate between the model and the data and make a prediction with the UI or maybe some sort of server we are running in the backend. So let us see how do we create a Flask app. So you can see here the same concept that we discussed, get and post. So now you take your pickle file, like you are having a pickle or maybe a jobly file. So can you all see that we are reading our reading our pickle file? Okay, here what we are doing, we are reading our pickle file. Like the model is saved as a pickle file or a jobly file. So what we are doing, that we are reading it here. Now what is the next step? What is the next step? So you load your model. Okay, you're inside a Flask app. Now you see we create an app.route. What it will do, it will make the prediction. That prediction, whatever we are doing with this pickle file, it is what it is doing. It is posting, it is sending to the server or maybe the UI. So you get your data. How do you get your data? By doing a get request. Then once you get your data, you have to pre-process, like whatever new data is coming. You cannot make a direct prediction. You all know I cannot go and make a direct prediction. There is some sort of pre-processing required. You do that and then you make a prediction. Okay. Then you make a prediction, and that prediction once you make, create it in a JSON format and then send it back. You run this main file, it will go and it will run. So this is how you create your entire thing and then you push it. So this is a structure of creating a Flask app and deploying that. So this code I'm going to share with you just to, so that you have an idea how to build this. So basically it's app.route. That's it. This route is a connector. Okay. It is doing post of whatever prediction you make. You're making prediction here. It is going to send it back to the server. So Flask is like a bridge between your model and the UI. It is helping with everything. Yeah, I put the charge. I saw it. I'll put it this. So I'm just going to upload these in the notebook where we are talking about building these Flask app. So feature importance we have done. Now let us look into the Flask app and then I'll show you those servers which are running right now, local servers. These are actually on certain websites which I'm running it. My system is becoming really super slow. Okay, so here I will try to create a new folder called as creating a Flask app. So let me call it as a model deployment. Okay, model deployment. In this I'll add all of them. Model deployment.
Alok, when we run that one, which will be the server?
This is going to be a local machine right now. We'll take a different server and I'll show you. Right now it will run on your local machine. So what it will do, it will create a dummy server. Okay, and
Okay.
it will run. Right now I think it will not run in this notebook because we have to run this in the VS Code and all to get that server running. So, but I'll show you the real server how it is running. So this is just to give you an idea how this is working. You can run it in the VS Code. So if you're having those where we run those .py files, we can still run it and we can see. So this should go inside your ML model, machine learning. Yeah, here. Now I'll show you real life example. How do we actually post? But you need to remember all this Flask and everything. Okay, that I have shared with you. Now, okay, this you may not be able to run, but just understand the architecture of what we are discussing. Like what are the components here. Now let us move to a real life use case. Okay, let us move to a real life use case. So here is certain use case that I have for all of you. There are three model prediction that we are having. Okay, there are three model prediction. Can you all look at this? So one is to predict the diabetes. Okay, other things are there. So we have these. If you see here, we are importing NumPy pandas. We are loading the data set. This data set is about diabetes prediction. Outcome is like 0, 1. Same thing that we were doing. Okay. Then you look at data set, do shape and all, describe your 0 means non-diabetic, 1 means diabetic, and then you prepare your X and Y, okay, like this. Further, what you're doing, you're trying to build a, like, one model we are selecting. Like here we are selecting support vector machine. You can select any other model like logistic regression. I'm just giving example. Prepare that model, make a prediction. Prediction is coming as 78%. Okay. So then you make a new prediction like this. If anything that is input, I'll make prediction like this. Now you can see we are saving the model how? As a pickle file. Can you all see this? We are saving the model as a pickle file. So this model will be saved as a pickle file. Here you have that save model folder. So how are we saving it as a pickle file? So we are saving it as .sav format. Okay, a different format but doing the same thing. So whatever data comes, it will be saving. So we are having three model in this. One is to predict the diabetes, one is to predict diabetes, one is to predict the heart disease, and one is to predict the Parkinson's. Same thing, our notebook. If you see, there is nothing different. Whatever we have discussed till now, everything is same here. Okay. So this is one example I'll take of diabetes. So we are going to use the same notebook to make the prediction. I have posted in my GitHub. You can take it from there. Now let us go to the part that is slowing my system actually. So this part is slowing my system. So this is what I was running in the server. Okay. I'll just close this part because this is a UI that I was showed you. I was talking about, we need to develop some sort of UI. Okay, fine. So let's see how does it works. How does it works? So I'll just close these also because we are running it on a real server now in some sort of website and we are checking this. So these all Flask and app, these are local. As you can see, when you run that, it will create something like this. Okay, that this deployment is a local server. Don't use it for production. The example that I gave you, simple Flask, if you run it on your machine, you will get something like this. If I click on this link, I'm not running this right now. So it will open a new URL here, but it will not run properly, as you can see, because this is not connected properly. There are certain configurations. But then we are able to create a Flask app, which we can be using it here, which we can use. So it creates something, you can run it on your VS Code. Okay, maybe if I can show it next time, I'll show it how it is working on the VS Code. But this is how it is there. So let me close this. We are not using this. We'll use the diabetes one. So we'll be using the diabetes one. Now, this code I want all of you to pay attention. Okay. So here we are going to use an app called Streamlit. Okay. We are going to use an app called Streamlit and we are going to run everything. This is actually slowing my entire system. That's what I was telling you. So in this one that we are doing right now, here we are running one. So first we'll clone the entire Git repository. So do I have it right now? Too many sessions are running. I'll close all the sessions. We don't require everything. Collab also consumes a lot of resources. The problem is that. Okay. So here, I think nothing is there. So what we'll do,
Collab, uh,
yeah,
collab, Alok, collab consume any local resources?
lot of. If you look at how much is your Chrome consuming, you will understand. If there are so many notebooks, it slows
Chrome
down.
is okay, but collab, what about the collab?
Yeah, because we are running Jupyter Notebook in Collab. So ultimately, it is all going to Jupyter Collab. This entire thing that we are running is on Chrome Notebook. So when you run Collab on Chrome, ultimately, even though it is cloud connected to the cloud, but then the entire this entire weight of what we are running, it goes to the Chrome Notebook. So Chrome is becoming very, very slow. Okay, if you're running very heavy model for basic task, it is okay, no problem. But then if you look at how much of consumption of Chrome is there, you will understand that okay, this is becoming very heavy. So it will be like 1 or 2 or 3 GB also. You can check that amount of. There are a lot of local files created. Okay, so basically local files
Okay,
will be in the Chrome, and those are actually causing a problem. Anyway,
okay,
so here we are running this. We are running this repository. Okay, which one? The one that I showed you here where we were having all this code. So we'll do git clone of this. Okay. So we'll do git clone of this file. So I'll just say git clone and I'll go to this. So from here where I have this repository, I can just go here and I can say git clone, okay, like this. I can copy this HTTP link, whatever is there. I'll just copy it. So let us go here in this notebook that we are running. So I just pasted it here. As you can see, I mentioned git clone and I pasted this notebook. Let us go and run this now. So we're just cloning everything from there, like we did cat and dog also. Okay. So here that entire repository will come. Okay. Entire repository will come. Now we are going to run a server. This is the real server. Okay. So to run this server, we are going to install that ngrock. This ngrock is nothing but, you can see we got this folder that is having all the notebook. Now we are going to install that. How do I connect with that server? So this is the server. Okay. ngrock, what it does, uh, this is my authentication token. Just remember that I have to copy this. But if you go to ngrock,
Look, when you're taking that authorization token, I think it got blurred in our screen.
oh, is it
Where
really?
you're going actually, uh, which website you're going?
ngrock. So
That
you just go to
NGO. Okay,
you just go to ngrock. So this is like kind of a server it will give us, where we will deploy our
okay,
models. We'll be deploying. So I'm just opening that ngrock website, which you can see. So ngrock, what it does, it helps to create the interface for us. Okay. So we are going to use
okay.
ngrock. So it is having, like, you can register on this website. You will get a server for this. So it is hosting that thing. So this is my as you can see, I can just copy this authentication from there. Before that, we have to run these. We have to install this ngrock. So I'm just trying to install, and all the requirement also along with this. So you can see it is running with all the requirements, whatever
So
requirement
before
we.
before this step, we need to create an account in this
Yeah, yeah,
NGRock.
yeah, yeah. You can do
Okay,
it after this also, but it is just installing right now.
okay,
Right now we don't require authentication. After this we'll require, but I'm telling you, you have to create that entire thing. So you can see it is installing all the requirement also by using the requirement.txt file. So normally pip install and all that we do. So what we can do, we can create a requirement.txt file. This is in terms of the deployment that we are doing. So you can see here we have a requirement.txt file. So if I go to this requirement.txt file, it will be having all the different versions that we require, all the libraries. So this txt file, it carries the detail of that. Everything is here. So I'm just opening this txt file. So you can see it is having numpy, scikit-learn, all these version you mentioned, so that in future it doesn't cause a version issue there. So coming back to this, we were trying to install. Now you can see this is installed here. So I'll go a little bit up now. Now authentication will be required. So you're importing all the libraries here, as you can see. Uh, so we require that ngrock here. Now in this, you have to put your authentication token, like whatever you're having. So I'm going to replace it with my authentication token. I'll just put it here. Okay. So what I will do, I'll just make a copy of it because I don't want to. I'll just comment it out like this. Okay. And this authentication token that I have got from it, you have to all have to register, okay, with your own these things. You will get this authentication token. So let us go and run this here. So I'll replace these with our own tokens that we have got. I'm replacing it with our own tokens, which we want to deploy there. Control V, why it is not coming? Okay, let me copy it once again. My system has become super slow. I have to close everything after this session and restart it. Okay, no problem. I can copy it from here itself and put it there. I don't know why it is not allowing me to copy. Okay, so you can see I can just copy the tokens from here and put it in my notebook. Okay, so I'll put the tokens here. I don't know why one more came. We can delete that. Okay, so we got the tokens. Let me just remove this part from here. Not required at all. D is going out from. Okay, I'll comment it out. Control Z. I'll put hash here. Timing I'm just commenting out. So let me run this. Okay. So what happens? This gets the token. Now you can see it is connected with ng block. Okay. You can remove these lines not required. Now further what we are going to do, we are going to change the port. Like we are going to run the server here. So our app.py file is having all the code. So remember this Python script that we are running in IPython notebook, you have to save it in a form that model runs. So the entire file, how do you prepared an app service of that? How you do that, we'll discuss it in maybe coming session. You saved it as a .py file. So here we are having that app.py file. It is nothing but our code in .py format. So we are running that, okay, in Steam lit service. Now let us start that service. So we are trying to say I want to start that service, and now you can see I'm running it. Now the server will start. So now we are telling the same thing which we did with that Flask app. Same thing, it will give us a server, but this is the public server which we can consume. Now you can see it is giving this server. I'm going to run this. Yeah, please go ahead. Somebody was having a
Look, your screen blanks out most of the time. No, I'm not able to see. Like,
I think because of too much of consumption, I need to restart that, but cannot do it right now.
okay.
Okay, let it run. Maybe you can go back to the recording, or I'll show you in the next session once again. Is it visible now? Can you all see the UI that has been created here? I think there is some comments also. Your screen is getting blackout. Is it getting blackout most of the time? Okay, do one thing. I'll stop everything. I'll stop unnecessary notebooks. Okay, I'll stop all the notebooks which are running, which are not required. I think that will be consuming. That is consuming some memory here. These apps and all are very heavy. Okay. I think my machine is also quite old. This is having Intel chip. So I'm just closing all the notebooks. Everything that is running, we don't require. I'll just close everything. So just give me a minute. I'll close everything. Only I'll keep this notebook running. The deployment part that we are seeing. Now I think I've closed some of these notebooks. So it has become little bit faster. So it is showing as if every notebook is consuming around 200 MB, 200 MB. That is a problem. Okay. No problem. Okay, let me share my screen once again. Now it should not black out, at least for the demo purpose. Sometimes even Zoom is also like it is also consuming a lot of bandwidth. So when you share the screen, it consumes certain bandwidth. Fantastic. It is asking me to. Okay. Can you all see my screen? Please let me know once you can see my screen. Is it visible now? Yep. Yes, now you can see, right? I've closed all the other notebooks. There were so many notebooks running, and that is why it is causing. So I'll just quickly discuss. So if you all remember this notebook that we were running, so we have just installed these ngrok. I've given the token here, and then what I'm doing, I'm trying to run. Now when I click on this link, okay, so we are just using an app here called a Streamlit app. When I click on this link like this, it opens a new link here. Okay, I'm just opening that new link. I hope everybody is able to see this ngrok new link that has been opened. So there are three models in that thing. If you remember, diabetes prediction, heart disease prediction, and Parkinson's disease prediction. So like number of, let's say there is zero pregnancy here. Okay, glucose level, let's say it is 145. Blood pressure, let's say it is 130, and skin thickness, I'll put it as 1. Insulin level, let's put it as 10. BMI, let's put it as 3. Diabetes, let's put some value here, 56. And age of a person, let's say 55 years. Now let us go and run this. So what will happen? You can see it is making a prediction. A person is diabetic. If I make it as 110, maybe I'll do blood pressure. I'll keep it as 100. Okay. I'll make it as 20. Age, I'll make it as 30. Okay. BMI level, I'll make it as 1. Let me run it now. Insulin level, I'll change it to maybe 4. Let me run this. Okay. So you can see it is still predicting. So basis of whatever our data is there, you need to go and check data. So there are three models in this: heart disease prediction and Parkinson's prediction. So you can see we have got a UI. This UI is connected to our model. How it is connected? By using a server. So what we have done here is that we have got this. As you can see, we are running this app, Streamlit app. So it creates like Flask was doing a local server. It Streamlit create a public server for us. Okay? So you all can go try this notebook. I will share this notebook with all of you, and you all can go and run this. Yeah, and you can do the testing on your own.
Uh,
So where have we deployed the model? Is it on the local
It
or?
it is on a public server of ngrok.
Okay. And
Alok,
this UI,
what way?
Yeah.
You please go ahead. Ashwin,
yeah,
is it?
yeah,
Yeah,
yeah.
please
Yeah.
go ahead.
The model is deployed on ngrok, and the Streamlit is running where? Is it on the local, or where are we running Streamlit?
It is on this website, this one, ngrok website. So you can see we have got that authentication token of that website. If you remember, when we were running this, we have actually used ngrok. So this is the website. What it does, it creates a public server for us. We are using this website. Now we need a credential for that. So for example, this is just a demo. You will
Mhm.
have your own company UI and something there. So there all these UI will come. So in place of this ngrok server that we are running locally, like putting, then your company website URL will come there, whatever is there. This is just to show you that okay, if I run it here, like it is creating, like you can see HTTP, then it is have that ngrok free app. Here we can replace it with our own company thing that we are running. Okay. So they are providing that. Yeah.
Okay, thank you.
Okay. This is just example for all of you. So please go and run this. I will upload this entire notebook. This is just one notebook that you have to try to run and see if you can get the output. So you can just register to ngrok, get your own credentials from there. Okay. Only thing that you need a credential. So the only difference between these and the previous Flask app is that Flask was having local these things. You can run it on VS Code. What I have done, I've used a server. This is running where on a public server of ngrok app. Same connection. We have just given a proper connection. That's it. And we have given a UI also. So it is actually putting everything on this UI, and you can see this is what authentication token that I have used, and this was what we got the like UI here. For example, diabetes predictions. So you can create your own UI. There's a different team that is working on UI preparation and all, but just to show you how it happens. So you need a Flask app with API connection and where you want to post your model output. So this notebook also I will share with you. Only thing that I need here is remove the credentials. That's it. Okay, otherwise, uh, you can have your own credentials. Okay. So I'm just sharing this
We could
notebook.
do this even on the local machine, right? I mean, NG-Rock is one, but we can do it on our local machine as well, right?
Yeah,
Deploying and
yeah.
using
Local.
Streamlit tab.
Yeah, you can do it on your local. I'm just giving example if you want to run it on local. Basically, when we are doing R&D purpose, when we are trying to work, so we need not to go to public, this server and all. We can do it on local. Same thing we can use and we can try it. So we can do some sort of research there and see how do I run it on local. So I'll share this
Okay.
file in the same notebook. Please go and try this. This is a dummy example. There is no company data. So no problem at all. You can run this. It's a example, but be careful when you're using an organization data. Don't try these apps. Otherwise, it could be a problem for you all. You never know that data security is a very, very big issue. But at least for testing purpose, some data from outside, this is not a problem. No, I don't want to add it in feature importance. It should go into the model deployment. So where is it going for the model deployments? Yeah, it is here. So I will add this notebook in this, edit, upload the notebook. Please go and play with this. This is, very interesting. At least we are learning something that giving us end to end how does it works? Like how do I go and deploy the model? So I'm sharing the notebook with you all. Go and play with this. Okay, done, shared with you. Okay, please go and check if it is updated.
It's in the classroom, right, Alak?
Yeah, it's in the model deployment. In machine learning, in model deployment, I'll just
Oh,
push it in the last after
yeah.
feature importance. You will
Okay.
find it there. So please go and play with both these notebooks, and I will stop here. Maybe I need to restart my machine. Okay, I think there is one question regarding the LLM. LLM prediction. Okay, let me see, because see there are certain metrics. We have certain metrics, we have certain score like Rauge and all. We have perplexity, these things. To check that, let me check. Okay, some resources, Vaidya, I'll share that with you. I'm really sorry, I've been busy both the days, got some guests at home, and in the evening also there's a session going on. It's like trying to find like little bit difficult. Normally we all have working days on weekdays, so weekend is very good. But anyway, I'll try to find some resource and upload it here. Fine. That's it, guys. Any question? I hope at least you got an insight on feature importance and the model deployment. How does it work? Now it is for you to go and explore, learn more about this. Yeah. Uh, we'll solve one or two use case next week. Again, we'll try to build a complete end-to-end. Let's spend next week also in machine learning only and little bit of Python. Let's build a complete end-to-end model. Now you all know how does machine learning model works. Supervise like regression classification. Now you know feature importance. Now you know about deployment. Let us try to bring it together next week and solve one problem. We'll take one data set and we'll solve it on that. I have got one feature in feature importance. How to check the feature is how to check which feature is selected. It will tell you the feature name, like it will give you some score and the feature name. Yeah. In the like what are the other questions that you're having? Please let me know. Anyway, next week we'll take again one data set, one project we'll take and we'll build complete model. How X train and X trace is split from the output. Uh See, basically it okay, let us take it next week. Okay, let us take it next week. I'll bring the data and we'll see how it is working. Okay. So as I said, I'll compile more notes for all of you for feature importance. Next week we'll take one data set. We'll try to clean that data set, do feature importance, deploy the model, like run the model, save the model as a pickle file, and then deploy that model in local. Like you all can store, you all can install VS Code in your local machine for next week. Let us run it locally and see how it is working in place of using this server. So let us solve at least one problem end to end next week. Okay, fine. Oh,
Yes.
yeah. So yeah, everybody's excited. Fine. We'll do it next week. So at least go through all what we have discussed so that you understand, how these different tools work.
Yes.
Okay. See you all next week. Bye.
Bye.